Okay, let's dive into the secret world of three materials that are literally all around you, right now. You probably don't even notice them, but trust me, they're the unsung superheroes of our modern world. They've shaped everything from the pans in your kitchen to the spacecraft exploring the cosmos. So, right off the bat, I've got a question for you. What on earth do a vintage radio, a bulletproof vest, and an oven mitt have in common? I know, it sounds like the start of a really bad joke, right? But the answer is actually pretty fascinating. The answer? They're all made from these incredible man-made polymers. Now, don't let that word scare you. A polymer is really just a giant molecule made of smaller repeating units. The easiest way to think about it is like a very, very long chain. And the chains we're going to look at today, they are truly something special. And look, these aren't just any old plastics or fibers. These were brilliant solutions to specific high-stakes problems. They were literally invented to do things that no natural material could. To break through barriers that were holding technology back. So, let's meet our first material superhero, Bakelite. This is the one that really kicked off the whole plastic revolution. I want you to picture it. It's the early 1900s. The world is electrifying, literally, but there's this huge problem. Early electrical parts get incredibly hot, and they need to be insulated. The materials they were using, things like shellac, would just melt or completely fall apart. They desperately, desperately needed something new. And that's when Leo Bakelite comes in. He took two pretty simple chemicals, phenol and formaldehyde, cranked up the heat and pressure, and boom. He created the world's first entirely synthetic plastic. And here's the magic trick. Once it was set, you couldn't melt it again. This was a total, absolute game changer. So, what were its superpowers? Well, it had two crucial ones. First, it was an incredible heat resistor. It just would not melt. And second, it was a fantastic electrical insulator. It perfectly solved the exact problem that inventors were banging their heads against. And its impact was just massive. All of a sudden, you could have safe, durable casings for radios and telephones. It can make reliable insulators for a growing electrical grid. And with its smooth, hard feel, it even found its way into jewelry and toys. It basically became the signature look of the whole Art Deco era. Honestly, Bakelite was everywhere. All right, let's move on to our next hero. This one isn't about heat. It's about pure, unbelievable strength. Let's talk about Kevlar. By the middle of the 20th century, the challenge was totally different. For stuff like tires, aerospace parts, and especially personal protection, engineers needed a material with an insane strength-to-weight ratio. They needed something stronger than steel, but as light as your average fabric. The secret to Kevlar's strength actually came from a happy accident by a chemist named Stephanie Kwolek. See, when you spin this special polymer into fibers, something amazing happens. All the long polymer chains line themselves up perfectly, like a brand new bundle of uncooked spaghetti. This super ordered structure is the source of its incredible power. And that power? It translates directly into its superpowers. It has ridiculously high tensile strength, which is just a fancy way of saying it's extremely hard to pull apart. And all of that strength comes in a package that's remarkably lightweight. This unique combination of properties, well, it resulted in a truly revolutionary new fiber, one that could do things no other material could even dream of. So get this, on an equal weight basis, Kevlar is 5 times stronger than steel. Just let that sink in for a second. 5 times stronger. That is an absolutely mind-boggling number. So what do you do with a material that strong and that light? Well, you use it to save lives, in things like body armor and bulletproof vests. You use it to reinforce tires to stop blowouts, to make ropes strong enough to moor an oil rig, and in high-performance sports gear for that tiny competitive edge. All right, our final material superhero is a master of adaptation, a true master of resilience. Let's talk about silicone, the flexible wonder. Now, the challenge here was different all over again. Industry needed a material that was just stable, something that wouldn't become brittle and crack in the freezing cold or melt and turn to goo in extreme heat. A material that could stay flexible and reliable no matter what temperature you threw at it. And the solution came from a totally unlikely place, sand. Seriously. Silicon, which is the main element in sand, is extracted and then converted through a chemical process into these long polymer chains. This creates a super strong and stable backbone for the material. And that is the real key to its resilience. Silicone has some incredible superpowers of its own. First, it's amazing temperature resistance. It's just as happy in a deep freezer as it is in a hot oven. But it also has this thing called biocompatibility, which means it doesn't react with human tissue. That one property alone opened up a whole new world of medical applications. And that versatility is just incredible. In our kitchens, it's the non-stick bakeware and all those spatulas. In industry, it's the seals and lubricants keeping machines running smoothly. In medicine, it's used for safe implants and tubing. And of course, in our homes, it's the waterproof sealant around our windows and tubs. So there you have it. 3 totally different problems, 3 brilliant polymer solutions. Let's bring our heroes together for one last look at how they've totally shaped our world. This really puts it all into perspective, doesn't it? Bakelite gave us heat insulation, which really paved the way for the electronic age. Kevlar delivered that extreme strength, creating a whole new class of protective gear. And silicone gave us incredible temperature stability, giving us unmatched flexibility in, well, just about everything. Each one of these materials was a monumental leap forward, a solution that really defined an era. So it kind of makes you wonder, as we face new challenges like sustainability and quantum computing, what's the next material superhero just waiting to be discovered? What amazing material is going to define our future? Thanks for joining this explainer.